For G part 1, we're told to let W represent the distance between the turtle and point D at time t seconds. And for G part 1, we have to use the expressions we've found earlier for G of t and D of t to write down an expression for W in terms of t. So it's just going to be G of t minus D of t, and we take the absolute value of that because we're just worried about the distance between them. Okay, so we have then W is equal to the absolute value of G of t, which we were given earlier, and that is 0.05 t squared plus 1.1 t plus 18, and then subtract d of t, which we had found to be 20 times sine pi over 8 t, and all of that was over sine of 2.37 minus pi t over 8. Okay, so that is G part 1. And now for G part 2, we have to therefore find when and where on the path the water first reaches the turtle. Okay, so that is when that expression W, the distance between them, is going to equal 0. So that is when W is equal to 0. So we're going to need to find the time that happens and then what the distance is at that time. So the easiest way to do this is just to use our graphing calculator. So we'll get the calculator up. Okay, so here's the graph of W, which was the absolute value of G of t minus D of t. So we just have to look for when it is first equal to 0, that function there. So we just analyze the graph, 0, and about there. Okay, so about 3.349. I'll just get a couple more decimal places there. And there it is, 3.34880 and so on. So we'll note that down. So for this function W to equal 0, then T must equal 3.34880 and so on. So the three significant figures, that is 3.35. Okay, so that's the when the water first reaches the turtle after 3.5 seconds, and then we have to figure out where it is on the path. So we can just plug that value of t into our function g of t. So we could just do that with algebra and work it out on the calculator, or we can graph it. So I will just graph it onto the graphing calculator. Okay, so there's the function g of t graphed. I've just used x instead of t. So we wanted to find when t was about 3.35. So all we have to do is go menu, trace, graph trace, and punch in our value for t. So I'll do the unrounded version, so about 3.34880 and so on. And we get there, the distance is 22.24 meters. Okay, so we can write that in, and we can say the distance 22.24 meters. So 22.2 meters south of A. Okay, and that finishes off question 9G, part 1 and part 2.